students, we are given this question. A road is running north to south, crosses a road going east to west at a point P. So we are given a point P. Okay, so you got roads running. So the direction, this is the north, okay, and this would be my east. Of course, this is going to be my west, and this is going to be my south. So a road running from north to south crosses a road running from east to west at a point P. So this is the point P. Now a car is driving north along the first road. So one car, let the car be car A. Okay. It is driving towards the north, okay, from the first road. So along the first road, so this is the road, and the car is driving on this road. That's the understanding. Now you got another car B is driving east along the second road. So you got the second road here, right? And you got this car, okay, this car driving along east, and you've got another car driving along north. So this is car B. At a particular time, car A is 10 kilometers to the north of P. Okay, so the coordinates for this is going to be 0, comma, some A of t, and the coordinates for this is going to be B of t, comma, 0 along the x-axis, along the y-axis. And we are being given that information. Car B is 15 kilometers to the east of P at speed is given to be as 100 kilometers per hour. So the change, okay, A dash of T is given to be as 80 kilometers per hour, and B dash of T, change in their position, or I would say the rate at which they are going. And B dash of T is given to be as 100 km per hour. Now, how far is the distance between the two cars? So, we are expected to find this distance. Okay, we are expected to find this distance. So, we have to do this question. So, we can start off by placing the following information. Okay, let A of T be the distance of the car A. Okay, be the distance of car A north of P. Okay, north of P at any time T. And let B of T be the distance of car B east of P at some time T or any time T. So by Pythagoras. So what do we know by Pythagoras? By Pythagorean law or Pythagoras theorem, if this distance is taken to be, say, some C of T, then we got the following. So by using Pythagoras, I can clearly write this as C of T squared is equal to A of T squared positive B of T squared. Now, differentiating with reference to T, we would get 2 times C of T times the differential of Ct. So that's going to be C dash. This is equal to 2 times A of T times differential of A of T. That's going to be A dash of T. Positive 2 times B of T, okay, times the differentiation for Bt. That's going to be B dash of T. So this is the way you have to write the differentiation. Now I can cancel the 2's off, and that's going to give me C of T times C dash of T is equal to A of T times A dash of T positive B of T times B dash of T. I've got something like this. Now I don't want to write this t's, okay, so I'll just write AA dash positive BB dash. On the left it's CC dash. Now I need to know the value for C dash. So C dash is equal to AA dash positive BB dash divided by C. So this is the value that I've got. Now clearly from the question, if you were to read the question, clearly A is given and the change in velocity and the change in distance is also given. Okay, so the speed is also given. So A is given to be as at a particular time car A is 10 kilometers to the north of P and traveling at a speed of 80. So change is 80 kilometers per hour. Positive B is 15 kilometers to the east at one particular time, and its speed, traveling at a speed of 100. So that's what the value that you need to place. Now you need to know the value for C. So how are you going to get the value for C? Now by Pythagoras, C is going to be, or in fact C squared is going to be A squared positive B squared. From here C is going to be root of A squared positive B squared. So this is the value for C. So that means you will have to have a square root of 10 squared positive 15 squared. And this would give me my C dash. Now if you were to evaluate this, C dash would be 460 divided by root of 13. Okay, and when you find out the value, it would approximately be 127.6 kilometers per hour. So this is the requirement that we need, that is expected in the question. So the question wants us, how fast is the distance between the two cars changing? So the distance between the two cars are changing at this rate. Okay, so this car is going. So car A is moving like this, and this is A, and car B is moving like this. This is the first instance. Okay, the next instance car B would be here and car A would be there. So this is one distance and this is the next distance. So on it goes. So that change, the rate at which the distance is moving or distance is changing, is given to be as 127.6 kilometers per hour. And this completes the question solution.